Today we are looking at a grade 10 question paper, Physical Sciences. It's paper 2, meaning it is chemistry. And we will only interested in question 4. For this lesson, we're only interested in question 4, not the whole of question 4. The other questions we'll do in the next lesson. So in question 4, we will do question 4.1, 4.2, 4.5, and 4.6. So let us read question 4. Question 4 says, study the table below and answer the questions that follow. So the table, we are given a table. It has 4 columns. The first column is the element or the ion, the number of protons, the number of neutrons, and then finally the number of electrons. So we're not actually given the actual elements or the actual element. We have, our task is to actually identify them. So we're just given placeholders. We have P, Q, R. And they say that element P has 11 protons, 12 neutrons, and 11 electrons. The element Q has 14 protons, 16 neutrons, and 14 electrons. And the element R has 16 protons, 16 neutrons, and then finally it has 18 electrons. So before we can even answer the question, let us unpack this table. But before that, so make sure you have a periodic table in front of you. When you're writing, you'd find it at the back of your question paper, and also have a piece of paper and a pen to write with. So yes, let us unpack this question paper or this table. Okay. You see that I've drawn my own table. I don't want you to get confused. Is it an element or ion, number of protons, number of neutrons, as well as number of electrons. You also see that I've added additional columns here, A, Z, E, or I, and I'll explain what all of them means shortly. So let's just remove this quickly. So in that table of ours, so P means, or P plus means a number of protons. And remember, the positive sign there is just to indicate that protons are positively charged. And then N naught just means number of neutrons. And remember, the 0 there is just to show that neutrons have no charge. And then E minus is just the number of electrons. And remember, electrons are negatively charged. So that's why I showed them that way. And then if you recall, in the table, we also had a new columns where we have, so just look at it, we have A or Z. So what do we mean when we talk about A? A actually indicates the atomic mass, and it is actually equals to the number of protons plus the number of neutrons. So keep that in mind. And Z means the number or atomic number, and it is actually equals to the number of protons. So let's just go back to our table. Okay, come. So here is our table. So we said that A is the atomic mass, and it is equals to the number of protons plus the number of neutrons. So we see that the number of protons for P is 11 plus the number of neutrons is 12. So that's just going to be 11 plus 12. 11 plus 12, we know it's 23. This means that the atomic mass for P is 23. We do the same thing for Q, 14 plus 16. 14 plus 16 is 30, meaning the atomic mass for Q is 30. And then for R, it's 16 plus 16, meaning that the atomic mass for R is 32. Atomic mass is just the number of protons plus the number of neutrons. So now let us go to Z, which we said it is the atomic number. But we've spoken about that. So we said that atomic number is equals to the number of protons. So we see P has 11 protons, which means atomic number is 11. Q has 14 protons, atomic number is 14. R has 16 protons, meaning that its atomic number is 16. And now you see here, is it E or I? What I mean, is it an element or is it an ion? So how would we then decide if something is an element or an ion? Remember, we don't know. So how do we then decide that? To do that, let's just go back to this note. So you see, so we said that, so we have some, if it's neutral or it's just an element, the number of protons would be equal to the number of electrons. So it will just be a neutral element or atom. And then if it is an ion, it can either be an anion or a cation. If it is an anion, the number of electrons would be greater than the number of protons. So it will have a negative charge. This element would have gained electrons. If it's a cation, the number of protons would be greater than the number of electrons, meaning it would have lost electrons. So gained electrons, and this one would have lost electrons, and then it would have that positive charge, because what that would mean that there are more positive charges than there are negative charges. It becomes a cation. If there are more negative charges than there are positive charges, it becomes an ion. So let's decide for our the things. So we're given PQR in the table. So let's decide, is it neutral or is it an ion? So to do that, we look at the number of protons as well as the number of electrons. We see P has 11 protons and 11 electrons. So it's neutral. It's fine. Q also has 14 electrons, 14 protons, as well as 14 electrons. So it's neutral. And then R has 16 protons, but if you look at the number of electrons, it's 18. So here, for these two, the number of electrons and protons are equal. So it is neutral. For this one, we see that electrons are much greater than protons. So we've said if the number of electrons are greater than the number of protons, this is an ion. So this is an ion and it is an ion. But then how many electrons did it gain? So we just have to see, okay, if it was neutral, it would have 16 electrons. But now it's not, it has 18. This means it has gained 2 electrons. So this element has gained 2 electrons. Okay, so now let us now go back to our this part of the table. So this is now how you would normally write when you write a chemical symbol, and we call this the X, A, Z notation. So the X is just the chemical symbol, and then the A is your, like we mentioned, your A is your atomic mass, Z is your atomic number. So we have the atomic number, we have the atomic thing. So we can write, so we have P, and then atomic, so its atomic number is 11, A is 23. But we haven't yet identified the atom. Okay, see that wasn't actually in the short. So let's redo it again. So we have P and its atomic, so in its atomic number, Z is 11, its mass number is 23. So we haven't identified what it is, we'll do that shortly. And then we have Q, its atomic mass is 14, and its atomic number is 14 and its atomic mass is 30. We still haven't identified, we'll do that shortly. And then R, its atomic number is, what did we say? It's 16, and its atomic mass, we found it to be 32. So now how do we identify which elements these are? We will actually have to use the atomic number. So we go to our periodic table and we will look for an element with an atomic number of 11, an element with an atomic number of 14, an element with an atomic number of 16. Then we'll actually be able to identify which elements these are. So this is our periodic table. It is available at the back of your question paper, And we said that we're looking for three elements: an element with an atomic number of 11, an element with an atomic number of 14, and an element with an atomic number of 16. So if you look there, they gave you an example of what all of these numbers mean. So the number there at the top is the atomic number. For copper, it's 29, and then the number at the bottom, 63,5, it is the approximate atomic mass. So that is the atomic mass. So now we are looking for an atom with an atomic number of 11. If you look there in group 1 of your periodic table, you'll see that the element sodium actually has an atomic number of 11. This means that P back in our table is the element sodium. Then we're looking now for an element with an atomic number of 14, and you search for it, and we see that silicon over there has an atomic number of 14, meaning Q back in our table is actually there. What do you call this? The element silicon. And then we're now looking for an element with an atomic number of 16, and they are close by, and that element is sulfur because it has an atomic number of 16. So now that we have identified the element, let us now go back to completing our table. We've identified these elements. So an element with an atomic number of 11, we found it to be sodium. So that will be 11, 23, and that is sodium. And an element with atomic number of 14 is silicon. And so it has 14, 30. And then an element with an atomic number of 16, we found it to be sulfur. 16, 32. But now be cautious to remember that we said that this element has actually gained 2 electrons. If it has gained 2 electrons, it is negative. So 2 electrons, and then it is negatively charged. Even so, the sulfur will also show that it has gained 2 electrons. And now we have unpacked this table. We can now move on to actually answering the questions. So the first question required us to provide a definition of the term atomic number. So the marks for that question was 2. And like we've mentioned, that atomic number just refers to the number of protons. So that is your keyword, number of protons, and you'll get 2 marks for that. So question 4.2.1 says, we need to provide the chemical symbol for the element Q using the AX notation. So we've already done that. Our job is now easier. We just have to go back to our table and copy that. So on our table, we had said that the element Q is actually the element silicon, which has an atomic number of 14, an atomic mass of 30. So how will this be marked? This will be for correctly identifying the element as well as using the correct atomic number. So question 4.2.2 is requiring us to write down the element P, Q, or R that is an alkali metal. So alkali metals are all elements you find in group 1 of your periodic table. And if you remember correctly, when we are identifying these elements, we found sodium to be in group 1, meaning sodium is the alkali metal. But look at your question. Your question is saying you have to use P, Q, or R. So we know the placeholder for the element sodium was P, and that you will get your mark. I don't think you'll get a mark wrong for writing sodium. So you can either write sodium or P and you'll get your mark. 4.2.3 requires us to write down the chemical symbol for R. So remember, we've already identified that R is actually sulfur because it has an atomic number of 16 and an atomic mass of 32. So it's sulfur. But when you're writing, you don't need, because there is just asking for the chemical symbol, you don't need to write the atomic mass or the atomic number. You can just write down sulfur, S, and then 2 minus to show that it has gained 2 electrons. Okay. So question 4.5 requires us to, okay, it says how many electrons that is an ion of element P have, and then the second part of the question is for you to draw the Aufbau diagram for this ion. So we've already identified that the element P is sodium, which has 11 electrons. So we know that it has 11 electrons. And now let's just draw the Aufbau diagram for the element sodium, not the ion. So to do that, remember to draw an Aufbau diagram, you just draw that, and then you have energy level 1, 2, 3, and then you have your 1s orbital, 2s orbital, your 2p orbitals, they're identical, and then your 3s orbital. So we know it has 11 electrons. Let us now fill these electrons up. How we do that is that the one electron has to be spin up, facing up, and then you pair it with a spin down electron. So that's 2 electrons. So we do the same thing for the 2s orbital. Now we have 4 electrons. But then for this ones, you first fill the individual orbitals with a single electron before you can pair them up. So now we are pairing them up. So that's now, this is about 10 electrons in total, 2, 4, 2, 4, 10. And then finally, the 11th electron. So it doesn't have a pair because we only have 11 electrons. So now sodium, because it's in group 1 and its valence electron is 1. So valence electrons, those are your outermost electrons that you find into your outermost energy level. So the outermost energy level is level 3. So it has a tendency to actually lose this electron. When it loses that electrons, it means that the number of protons will now be greater than the number of electrons, meaning that it will become a cation. So it will be positively charged. That's why here, to indicate that it has actually lost an electron, I'm writing it with a plus. If it had gained, remember previously with sulfur, we said it has gained 2 electrons, we wrote 2 minus, but this one has lost an electron, so it's plus. So now if it had, when it's neutral, it has 11 electrons, it loses the 1 electron, it means it's now left with 10 electrons. So that's your answer. So the ion of element P here will have 10 electrons. So now the Aufbau diagram for this is just going to be similar thing. You do the same thing, but now it only has 10 electrons. So you get a mark for that and a mark for this, and also that mark for 10 electrons. So yes, this brings us to the end of this lesson. Thank you for watching. Remember to subscribe, like, and share. Thank you.